2.3 is about factoring polynomials as well as using synthetic division. Before we can jump into synthetic division, we really do need to remember how to use long division. Okay. So let's have a quick refresher. If you have like 372 divided by, let's say 20, let's just say 2. We'll make our life easy. What you're doing is you're saying, okay, how many times does 2 go into the 3 first? Well, 1. And 1 times by 2 gives us this 2 that we drop here. And then we would subtract and get our 1. And then, of course, 2 can't go into 1, so we have to drop down our 7. So 2 times, how many times does 2 go into 17? That's, of course, 8. 2 times 8 is 16, so we subtract that and get our 1. We drop down the 2. 2 goes into 12 6 times. 2 times 6 is 12, which means we have a remainder of 0, and this goes in perfectly evenly. So the idea behind polynomial long division is the same concept. So we started with saying, how many times does 2 go into 3? Well, how many times does x go into x to the third? In other words, what do you need to multiply by x to get x to the third? The answer is x squared. And then what we do, just like how we did 1 times 2 to get 2 here, we're going to take this x squared and we're going to multiply it by this x minus 2 over here. So x squared times by x is x to the third. But of course, when we multiply this by this, we have to also multiply by the negative 2. So we get x squared times negative 2 is also a negative 2x squared. And then typically we would subtract. I prefer to add the opposite, but please recognize it's the same thing. So your x to the thirds should cancel, and 4x squared plus 2x squared should give you 6x squared. And then we drop down the next term, just like we did when we dropped down our 7. And we do it again. How many times does x go into 6x squared? In other words, what do you have to multiply by x to get 6x squared out? Well, you need to multiply by 6x to get 6x squared. And then again, we take this and multiply it by all of this. So 6x times by x, as well as 6x times by negative 2. So 6x times by x gives you 6x squared. 6x times by negative 2 gives you a negative 12x. And then again, typically we would subtract. I prefer to add the opposite. So your 6x squareds go away. And you end up with a 7x with a negative 14 dropped down. Then we do it again. What do you have to multiply by x to get a 7x out? Got to multiply by 7. Then we have to do 7 multiplied by x and by negative 2. So 7 times x is 7x. 7 times negative 2 is negative 14. We add the opposite. And of course that comes out to be a 0 remainder. So what this means for us as far as our division goes, what we're saying is that if you take x minus 2 and multiply by x squared plus 6x plus 7, that should equal x to the third plus 4x squared minus 5x minus 14. So if you wanted to test this, you could certainly multiply all of these together just to double check what we need to do. So I'll do that really quick. You don't necessarily need to, but I would like to show it to you. And just kind of how I organize my thoughts when I do this. So I do x times by x squared, which is x to the third. And then x times 6x, which would give you 6x squared. And then x times 7, which would give you 7x. But then you also have to do 2 times x squared, which will give you a negative 2x squared. And you'll notice that I put it down below. I don't keep going out here like a lot of teachers do, which is fine if that's how you choose to do it. How did I lose this? Okay, so a lot of people will just keep going out to the side here. I don't. I try to match up my like terms as they happen. So the negative 2 times 6x is a negative 12x, which I will line up my 7x. And then lastly, negative 2 times 7 is a negative 14. And it's out here because it doesn't have a like term. And then I like to add them like this. So we get x to the third plus 4x squared minus 5x minus 14, which is sure enough what we started with. That's good. That means we did it correctly. Okay, so I'm going to go ahead and erase those markings. We don't need them. But I just wanted to show you that that truly is the same thing if you were to multiply it out. It's just that we had to find a way to go backwards, right? We had to find this from the end result. All right. So one more long division practice problem here. Again, what do you need to multiply by x squared to get to a 5x to the third? So we're definitely going to need a 5 because we don't have a coefficient here. And then we need one more x. So we're going to multiply by 5x. So 5x needs to multiply in to every term. So 5x times by x squared is 5x to the third. 5x by negative x is going to be a negative 5x squared. And 5x times by 3 is a plus 15x. Okay. Subtract or add the opposite. Negative 8x squared plus 5x squared is negative 3x squared. 24x minus 15x is plus 9x. And minus 6 at the end there that we dropped down. Again, what do you have to multiply by x squared to get to negative 3x squared? The only piece you're missing is that negative 3. And then we have to, again, multiply by each term. So negative 3 times x squared is negative 3x squared. Negative 3 times negative x is plus 3x. And negative 3 times by 3 is negative 9. Again, I'm going to go ahead and add the opposite. So those will cancel. That leaves us with 6x plus 3. Now, there is no way to multiply something by x squared and get 6x because this is a lower degree. So what that means when we run out of ways to do it is that this is your remainder. So how we would write this is you could say, okay, so 5x minus 3 multiplied by x squared minus x plus 3 plus 6x plus 3 is what would give you this whole number. Okay, so that's what you're saying. So, and that's what the remainder theorem essentially says, is that if you take your quotient and multiply it by your dividend and add your remainder, then you'll get the original. So, so that's your divisor, your quotient, and your remainder, and then it should equal the dividend. So if you guys remember, this is your divisor, this is your dividend, this is your quotient, this is your remainder. Okay. All right, and again, it just says if you have a 0, essentially, multiplied by whatever your quotient was, plus the remainder, you're going to get your original polynomial. Okay, so we're going to go ahead now and do some synthetic division. So I'm hoping that you're noticing that this problem seems very familiar. Okay, so let's talk about the synthetic division part of it now. So there's a very strict process with synthetic division. So the first thing you do is you write out in your little box over here whatever the opposite of this one is. Okay, so you solve for 0 in order to get what you put in the box. That's where this 2 comes from. Okay, and then we put the coefficients from all of these in a line, and we put our bottom down here. Okay? Every single time you're going to drop those coefficients down. And then the process tells us the very first one, we just drop it straight down. Okay? Next, we do this one multiplied by this one and put the result here. So 1 times 2 is 2. And then we always add down. So 4 plus 2 is 6. And then we repeat. We do 6 times by 2 and put the answer here. Then we add down. Negative 5 plus 12 is 7. Then we do 2 times 7 and put the result here. And negative 14 plus 14 is 0. Now, this last number is always your remainder. If you get a 0 there, it means that it divided evenly. Okay? So, what we can say with this then is that this becomes an x squared. It's always one less degree than you started with because we did x to the third and divided by an x. So this is going to be an x squared term. This is going to be an x term. This is going to be a constant term. So this is saying x squared plus 6x plus 7. That's what 167 means. Okay? So what we are saying then is that x minus 2 multiplied by x squared plus 6x plus 7 equals the polynomial that we started with. And I hope you'll notice that's the exact same thing we got above. Okay? So you might notice, okay, so where does this one even come from? Where does this one come from? Well, it comes from this, essentially. Okay? That's the result there. And then why do we do 1 times 2? Well, because we would have done 1 times by 2 to put here, which is what we put here. And then we would add the 4 and the 2 to get 6. And then we would multiply here to get this guy. Okay, so then we do the 6 times by the 2 to get the 12. And then, of course, we do negative 5 plus 12. And we get our 7. So here's your 7. So 7 times by 2 gave us the 14 that shows up here. And we add down and get 0, just like there. So that's why this process works, okay? But again, it's just saying, it's using the coefficients instead of the full-fledged polynomial. So let's go ahead and do another. So I have already set this one up, but remember, all you have to do is do x plus 1 equals 0, subtract your 1, and x equals negative 1, so that's what you put in this little corner. The negative 6 is the coefficient here. There's a 0 here because there is no x term. So anytime you see, so this one was an x squared, there is no x term, and then we have our constant. But in order to make the division work properly, you have to put this placeholder in to say, hey, this x spot doesn't have anything in it right now. Okay? So again, first number just drops straight down. Then we multiply these two and put the answer here. Then we add straight down. So 0 plus 6 is 6. And then we do 6 multiplied by negative 1 to get negative 6. And 7 plus 6 is 1. So what this is saying is that negative 6x plus 6 multiplied by x plus 1 plus a remainder of 1 should equal negative 6x squared plus 7. So let's check. Negative 6x times x gives me negative 6x squared. Negative 6x times by 1 gives me a negative 6x. But a positive 6 times a positive x gives me a plus 6x, which is why those two disappeared. And then 6 times 1 gives me a 6. But of course, 1 plus 6 is 7. Okay, so when I asked you to find the quotient and the remainder, here's your quotient, here's your remainder. Okay. All right. Given that you have this polynomial, it wants us to find p of negative 2 and p of 5. I'll explain why in just a second, but let's actually go ahead and figure out what those would be. I would just plug this all into a calculator. Okay, so let's go ahead and get a calculator up here. Okay, so I would just go ahead and plug this all into a calculator. Parentheses, -2, parentheses, oops, I missed a negative there. -2, parentheses, to the third power, minus 6 times by -2 squared, minus 5 times by -2 plus 30, which comes out to be 8. Then this one is going to be the same thing, but this time it's a 5. And this comes out to be a -20. So the reason that we care what those two are is because P of -2 is 8, whereas P of 5 is a -20. These changed signs. So on our graph, we somehow went from up here to down here, which means somewhere in there, we had to have crossed our x-axis. So the reason we care is like, hey, there should be a 0 in between -2 and 5. We know that 6 is a 0, but again, if we're at -2 here, and 5 here, and we had this up here and this down here, well, 6 is over here. So, like, yeah, I know it comes back up and crosses here, but I also know that it's got to cross somewhere over here. So that's the one I'm looking for. So again, we know that x equals 6 is a 0, so we stick our 6 in the box, drop our 1, multiply by 6, and put the answer there. That makes 0. 0 times 6 is still just 0, so we're going to drop down our -5. -5 times 6 is a -30, which makes 0. Okay, so we started with an x to the third, which means that this is an x squared plus 0x minus 5. Of course, we don't actually need to write that plus 0x, so we just write it as x squared minus 5, and we know that x minus 6 would be the factor for this. Okay? And we didn't get a remainder, so that's good. However, what it asks us to do is find the remaining zeros and write in factored form. This is factored form, but that is not the answer to what the zeros are. So the zeros, one of them is x equals 6, and it comes from this factor. But the other two, we need to set x squared minus 5 equal to 0 to find the other two zeros. So we would add 5 to both sides and get x squared equals 5. And then we would have to square root it, and we would get that x equals plus or minus the square root of 5, which are the other two zeros. So here are your zeros, here is your factored form. Okay. All right, here's another one. This one tells us that given the polynomial 4x to the fourth minus 28x to the third plus 61x squared minus 42x plus 9, and that c equals 1/2 is a 0 multiplicity of 2, and it wants us to find the rest of them. Okay, so first of all, it means that you can put 1/2 in here, and you will get a 0 remainder. Having a multiplicity of 2 means you can do it again, and you will get another 0. Okay, so we're going to drop down our 4, multiply by half, which gives us 2. We've got a -26. It may be easier if we get rid of this for a second. So -26 times by half is -13. 61 minus 13, let's see, I think it's 48. 48 divided by 2 gives us 24. I better check these numbers. Okay, so negative 42 plus 24 is negative 18, and negative 18 divided by 2 is a negative 9, which gives us a 0 remainder. Which, if this doesn't come out 0, we did something wrong, because it told us it's a 0. It should come out 0. Alright, but it also told us multiplicity of 2. So we're going to do it again. Okay. So drop our 4, divide by 2, add down. Divide by 2, add down, divide by 2, add down. Again, if that doesn't come out as 0, we did something wrong because it told us that it was a 0. The reason that it's useful, though, is that now we can say, okay, well, this was the equivalent of 4x to the third minus 26x squared plus 48x minus 18. This one is equivalent to 4x squared minus 24x plus 36. This is far more workable than a to the fourth or to the third polynomial is. In fact, this one has a GCF of 4. Keep in mind, we did already know that we have x minus 1/2 as well as x minus 1/2 as factors also. But this is now factorable. We can put it into our x with 9 on top and negative 6 on the bottom. And in fact, it's negative 3. So 4, x minus 3 times by x minus 3 times by x minus 1/2 times by x minus 1/2. So this is kind of a trick because we do not like to leave these fractions in here. It's very bad form to do so. So what we actually do is we say, okay, x minus 3, multiplicity 2 there. But this one, we're actually going to split this 4 into a 2 and a 2. Remember, order of multiplication doesn't matter. So ultimately, yeah, that would have given us a 4, but order doesn't matter. And the reason that that's helpful is because now I can multiply it in here. So now it's 2x minus 1. And in fact, this is also that, so you can square it. So now that we have our factored form, what it really wants is for us to find the real zeros. Well, the other two zeros come from here. All we have to do is x minus 3 equals 0. So our other two zeros are both at x equals 3. If we look at the graph of this, it may be helpful to you guys to see why this happens. Oops. Okay, so this is what that graph looks like. Hopefully you can see that there is definitely a bounce happening at 1/2 as well as a bounce happening at 3. So the zeros are 1/2 and 3, each have a multiplicity of 2. 2 plus 2 gives us our